Well, hi folks, it's Cliff here, a toolmaker from down under. I'm back again. Should be the final video on the series of making the ThreadExpress spindle and nut. And I'll be machining up some nuts in this video with some tips and tricks on lathe machining. It needs to be a very accurate nut, a close fit, in order for the ThreadExpress to be an accurate machine. If you're not familiar with ThreadExpress, it's an indexing and pitch generating mechanism that allows you to thread mill on a milling machine. I'll probably run a little clip just to show us what it can do, but this clip will be different with new information on machining parts in ThreadExpress just for a few seconds. Because I've got my 3-jaw chucks ground concentric and angularly in axial alignment that way and radial alignment, I can do 99% of round part holding in my 3-jaw chucks. If you're interested in that subject, I've done a video called Fix Your 3-Jaw, how you can make your 3-jaw really accurate and close down on a parallel part, nipping at the front first and then coming into parallel alignment with the part. So I can use my 3-jaw chucks for almost all my jobs, but occasionally you have a special requirement. In this case I'm going to use my soft jaw chuck. Actually, for the first time, I got this soft jaw chuck with my Tormark CNC lathe, but it's just been sitting there on the shelf for years. But this is an ideal situation for a soft jaw, so I'm going to bore it out so that I get a big arc of contact on these very thin wall bronze nuts. And so I've put a washer down in there, you just see it there, so that I can close the jaws up on that washer, and that takes all the slop out. And there's quite a bit of slop in this chuck because it's quite a cheap Chinese chuck, mass produced down to a low price, but it shouldn't matter too much if you tighten it up on a washer there before you bore it out. Then that racks the jaws round in their slop and takes all the clearance out in the direction that you want for tightening, so that when you're tightening it, it's already taken care of all that slop, and now when you bore the size, it'll tighten down parallel on your part, in this case like a bronze bush that is going to become a nut. Okay, so I'll bore it out now to take the nut outer diameter. It's quite a cheap and nasty mild steel, so it's not a bad idea just to give it a coating with cutting oil. It improves its machinability quite a lot. I'm not going to put coolant on it because with those jaws it's going to spray everywhere. So I'm using a cheap Chinese tip, like a lot of you guys. For special shapes it's quite handy to have a selection. If you loosen the screw off until it's almost out but not quite, so that you can see the tip is all loose there now, then when you blow it with compressed air, just simulating it really, then you get all the chips out from under the screw and around the back of it, and clean everything then with the compressed air before you turn it round. It's a quick way to clean the whole thing. Sometimes when you're midway through a job and you just want to spin the insert round for a sharp edge. Well, that's it bored out to 36 millimeters, the nut OD, and you can see I've stopped short of going right through so that it has a step, and that should stop the part from creeping lengthways. A reminder here to check your soft jaws and the scroll jaw section behind them is sufficiently clear. Mine are rather close, so I'm just grinding half a mil off there just to be on the safe side. There, I've got a length of bronze hollow bar in there. This is just a basic bronze and LG2 grade. It's nice and softer machine and reasonably low cost. It's a very low stressed application, a nut in ThreadExpress. The screw turns slowly in it, and it's lubricated with grease or semi-fluid grease, and it's very light loads, so that will be plenty adequate for that application. It's nice to machine. So if you're making more than one, or you have a bit of stock, then you can just protrude a piece out of the chuck, machine the outside diameter and the inside diameter all in the one setting, and then part it off. Of course, if you're only making one spindle nut and you've only ordered one piece of bronze and it's just that long, and you could hold it in the chuck something like that, just turn this portion here down to size, and then put it in your soft jaw as far in as you can and do all the finish machining in there. 2 cuts and a finishing cut down to 36 millimeters. See if I can show you honing a tool. So here I've got these easy lap diamond hones. This is a super fine. That's probably the right one to use with a new hone, but a fine is okay once it gets a bit worn. And I put just a trace of kerosene on it, and see if I can show you here. So I'm putting the lap up against the part with the right rake angle. You can see that's too much rake angle there. And when I tip it in until it's at contact at the top edge, then that's the right angle. Hopefully that's magnifying about right. And get it lining up along that edge there, and then try and get a steady vertical motion. Not a rocking motion like that, but a nice vertical motion. And you're moving your whole arm, and then gradually get the feel of it until you can start to see tiny little particles coming off, or at least kerosene coming off the top edge. Hopefully you can see that. Now I'm going to start to roll around the corner, and you've got to anticipate the clearance on the other edge there. And my head's probably in front of the camera, is it? Coming back round that radius, depending on how big a radius you want. It cuts pretty quickly. And that type of motion will give you a really sharp edge. And in order to see how well you've lapped it, you need to get the light right. See if I can show it. Pretty difficult to film this, but you've got to try and lap right up to the cutting edge without rounding the cutting edge, or without missing the cutting edge. I use diamond hones every day, and over the years I've probably got through and worn out 20 of these. The great thing about them is that you can sharpen tungsten carbide inserts and bits and high-speed steel and just get a beautiful razor sharp edge that allows you to cut to tenths or microns. It's obviously really important to have your tool on center, especially for boring work, especially small diameter boring work. So I've got a tall sleeve that I faced to the center height that sits on that tailstock flat on the lathe bed for each of my lathes, so that I can quickly set the tool to exactly center height. So the outside turning tool we've called ABS, and this one we're going to call tool offset number 1. And that last little cut was just in a little way for me to measure 28.1 in theory, checking the temperature, so it's going to shrink a tiny amount when it cools down, but I'm not working to microns for this. I've got to bore it out to 28.4, so now I can measure that tiny cut there, which will sort of be similar amount of spring to the finishing cut, and put the final cut on. So I want a big chamfer thread depth for the inside. Just slow it down a bit. And just a small chamfer on the outside. But the tungsten carbide tool I do swear by is the Iskar parting tool, and a 2mm wide tool I find is good for even deep parting in high tensile steel or tool steel. Of course, this is an easy job for it, but it's just the absolute best parting tool. So we're going to part off at 47.1, so that it cuts 45.1. Speed it up a little bit. Of course, that's a dead easy job for a parting tool, but I would use that to part through a large diameter piece of tool steel, and I just was never confident doing that with high-speed steel. So carbide wins in some situations, definitely. And of course, gripping it to machine the other end is pretty easy with the soft jaws already set up. It does look well grasped in there, doesn't it? See how concentric it is. Well, that's pretty good. So for the internal threading, I've installed a multi-form, I think in the UK, according to a comment, they're called partial form or universal threading insert, which has a sharp point and covers a big range of threads. And I'm going to, with my diamond lap, I won't do it now, but I'm just demonstrating it. I'm going to lap a little flat on there, and see if I can show you here on the drawing. So this shaded part's the female thread, the nut that I'm going to cut, and I want, where's my tool? So this sort of simulates the boring tool coming in there. I want it to go in a bit deeper than the crest of the male thread. That's the crest of the male thread there, and that width there, if I lap a flat on that internal tool slightly smaller so that it comes across there, then it must be deeper. because in order to get the fit I will have gone in deeper. So if I measure the actual little thread crest width there, I get about 0.35 of a millimeter. So I'm going to lap a flat on there of about 0.25, something like that. I could leave it sharp, but then I'd have to bore in all the way to there, which would weaken the nut unnecessarily. I could stone the same size flat in it, but then I'd run a risk it would be dragging on the top of the crest and giving me sort of an artificial fit. So I really want it to be just above there. So maybe about 0.25 of a millimeter flat I will lap on there now. So when I was lapping the flat, I deliberately gave it more clearance because you don't want less clearance. So I'm angling the lap further in, further down. How close can I get with the camera? You can see the flat there now. It looks quite obvious with the light shining on it. I've probably gone about 0.3 wide on there. And that saves going unnecessarily deep with the tool. Probably can't show this exactly, but you can see the little flat there. And the intention is that it is smaller than the crest of the male thread, so that I have to go deeper with the tool, which of course is that way, deeper that way. Okay, now we're ready to cut the thread. I've set up the gears for a 3.5 pitch, engaged the lead screw. I'm doing it in my most accurate smaller lathe, which is a little bit inconvenient because I don't have a brake on the spindle, but oh well, a little bit of excitement. So I put some ink inside the bore and checked it with my thread gauge to make sure I haven't done anything totally wrong. I'm ready to start thread cutting. I probably won't go into this too much because I'll be just doubling up the information that I did in a recent video already called Learn Internal Threading or Precision Internal Threading. It's a recent video, 2 or 3 videos back. You should be able to find it within the last few months anyway. So have a look there if you want some more information on this, but I'll just put in a bit of footage now. Okay, so that's roughed out now. I've got about as close as I dare go, and I'll start shaving it out. The threaded spindles of ThreadExpress are quite important to get accurate. They're not just lead screws for providing the master pitch, but they're also the guidance for the pivot on the end of the ratio arm. And so the better the fit, the better will be the accuracy of ThreadExpress. And so this thread should match between the nut and the screw like that. If you get your angles slightly wrong and you've not got the angles right, then you're going to get wear much more rapidly on the points of contact rather than on a big area flat of contact. And once you get wear, then the whole screw and nut can rattle around, and that will vary in its lengthways alignment position and affect the ratio. So it's worth spending a few seconds, or let's not exaggerate, a few minutes dialing in the position of your boring bar and your turning tool is in line with the axis of your lathe to be more sure that the angles of the flanks of your thread are going to match flat for flat. So the nut wants to be cut to a close fit on the screw, but not so close that it's tight, because you've got to have lubrication in there. So looking at the sectional drawing, we want the angles of the flanks to match and not be like that, but also enough clearance so that there's lubricant in there and it doesn't ever bind up, but not so much clearance that it's rattling around, because that is a bearing diameter as well as a lead generating helix. It's a bearing diameter to position the main spindle pivot over the center line of the pivot, and if it was loose on there, then the pivot position would vary and it wouldn't generate accurate threads. And that's why I think a V-form thread is best for a ThreadExpress spindle, because it's not just generating the lead helix but also acting as a bearing. And if you were to use an Acme or square thread that's used more often in lead screws, that might be good for generating the lead helix, but not so good as a bearing diameter to keep the pivots on the center line of the spindle. If it was an Acme or square thread, you'd be trying to use the inner and outer diameter of the thread as the bearing diameter, and that would be very difficult to machine. So ideally you want the spindle to be a close fit in the nut. You know, half a thou or so clearance would be ideal, just enough for a layer of fluid grease. You don't want it flopping around on there. I get a bit of spring in the whole spindle there if I just flex on it, so I've got to make sure I'm not measuring the flex or the spring. So there we've got about 1/100th of a millimeter. This is my second one. Got about 1/100th of a millimeter spring. So taking that into account, I think there's about 1.5 clearance there. So that's almost as close a fit. Well, that pretty much wraps up that video. If ThreadExpress is new to you, have a look at some recent videos on my channel that explain it more fully, and also different videos on machining components for ThreadExpress. Also, Mark Pressling in Queensland, Australia is building one of these and has a build video series on it. And my voice is getting croaky. It's supposed to be summer here and it's freezing cold. Please like and subscribe if you haven't already. Please let me know your thoughts in the comments.